Greetings, math fans. All right, so this is the second day of related rates. All right, I want to do this example. I think it's a really, really good example because it shows a couple different things that we talked about yesterday, but also I kind of show you one more thing here. So let's just get on with the example. All right, sand is falling in an hourglass at a rate of 5 cubic meters per minute. Okay, well, right off the bat, you see a rate there, and so we got dV dt, right? The volume is changing at 5 cubic meters per minute. Okay, into a conical shaped pile. The height of the pile is always 1/3 of the base. So the height is 1/3 of the base, and we're talking about base diameter, right? And it says the question is, how fast is the height of the pile changing? So of course we're looking for dH dt, right? dH dt. So how fast is the height of the pile changing when the pile is 10 meters high? Okay, so that means our height is 10 meters. Okay, you can't just plug it directly in though, right? Because you have to take the derivative first to figure out our answer. All right, so the first thing I'm going to give you guys is the volume of a cone. Okay, the volume of a cone is 1/3 pi r squared h. And what we're given, again, we're given dV dt, which is great because we're going to take the derivative. And I'm trying to find out dH dt. So do you guys agree? I really need to get this part right here in terms of h. Okay, so what I need to do is well, first of all, here it's the diameter. So let's rewrite this right off the bat here. Don't you guys agree? This is h equals 1/3 times 2r, because we got to talk about the radius. So really the height is 2/3 r. So again, this volume equation needs to be in terms of h. So I need to solve for r, so I can plug r into there and just have h in, right? So r is equal to 3/2 h. Okay, and then I take that guy and I plug it right into there. So I get volume equals 1/3 pi times 3/2 h and squared times another h. Okay, and if we simplify that, we get, I can show a little work here. 1/3 pi times 9 over 4h cubed, right? So volume is equal to 3/4, because it reduces 3/4 pi h cubed. All right, so let's move down here a little more. We're going to do dV dt, right? Take the derivative with respect to t. dV dt is equal to 9 pi over 4 h squared dH dt. All right, and then I need to solve for dH dt. So I get dH dt is equal to dV dt, and then if you divide by that, you end up getting times 4 over 9 pi h squared. Hope you guys agree with that, right? It's just algebra here. Okay, so we can plug some stuff in now. dH dt is equal to dV dt, which is 5 times 4 over 9 pi times h. Now, this is where we use our value of h. h is 10, so 10 squared. All right, and you simplify that, you get 20 over 900 pi. That's a lot of pi's. And that's meters per minute. Now, this is the deal, math fans. Make sure you're careful with the units here. This is give answers in millimeters per minute. So how many millimeters in a meter? Of course, 1,000. So I get dH dt is equal to 20 over 900 pi times 1,000. And in this case, I'm going to round it to 2 decimal places. Of course, on a test or quiz, I would always tell you how many places to round it to, but you wind up getting 7.07 millimeters per per minute. Okay, that's your answer for that problem. Okay, that's pretty straightforward. I mean, I think we've done problems like this already. This is from yesterday. Let's look at the next part here. It says, how fast is the radius of the pile changing when the pile is 10 meters high? And again, give your answer in millimeters per minute. Now, some of you guys are like, well, Mr. Crevice, what I can do is I can just do this whole thing again. I can say V is equal to 1/3 pi r squared h. And instead of plugging in r into that, I can plug in h into that and have it all in terms of r, right? I mean, that makes sense. Why would you not want to do that, right? But the deal is that I already have a relationship between r and h. Right? Do you guys agree with that? So let me write a couple things down here, math fans. Okay, so like I said, we can plug it into, we have this our equation, V is equal to 1/3 pi r squared h. We can plug that into h and get all in terms of V and r. But actually, that makes it even kind of confusing because look at the question here. It says, how fast is the radius changing when it's 10 meters high? If I actually get rid of my h, I'm kind of in trouble, aren't I? Because now I have V and r. I don't even know necessarily what r is, though I could plug the h into the equation to figure it out. But check this out. We already know dh dt. Right? That's 7.07 millimeters per minute. And we have h is equal to 2/3 r. So why not just use this relationship already, since we already have one of the variables? If I take the derivative of this, I'll have a dh dt, I'll have a dr dt, and I'll have, well, actually, we'll notice that we don't even use the value of h here. Okay? So first of all, before I take the derivative, I'm trying to find out how fast the radius is changing. So I'm really looking for dr dt. Do you guys agree with that? I hope. So I'm going to solve for r. Just makes it a little bit easier, right? If I get r is equal to 3/2 h, I think it's a little bit easier because then when I take the derivative, I just get dr dt is equal to, and notice what's going to happen. If I take the derivative of h, what happens? It just goes away, right? That's just, turns into a constant. So it's 3/2 and then dh dt. Sweet! I have dh dt. That goes right into there. So really, dr dt is equal to 3/2 times dh dt. And let's keep that, I'm going to use my exact answer. I never use a rounded answer. It's always bad to use a rounded answer in a problem. So that's truly what I have here, right? 20,000 over 900 pi. Okay? And then you multiply that out, you get 100 over 3 pi. And that's already in millimeters per minute because that's the unit I used before. So my answer then is going to be 10.61 millimeters per minute. That's it. So it's a lot easier if you have information given already. Why not just use that information? I knew dr, or I knew dh dt, so why not just use it? And again, I have my relation between h and r, and I just took the derivative, and I'm good to go. All right, that was actually a pretty fast problem. Just kind of understanding a little bit, what you have. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.